I remember too a summer when peace and war battled for possession of the creek and for all of Florida. The conflict was grave for us. The enemy was the Mediterranean fruit fly.
We are at the home of Marjorie Kinnan Rawlings. The passage we just heard is from her 1942 book called Cross Creek. She was describing her experience and that of her neighbors here in North Florida with an outbreak of the Mediterranean fruit fly in 1929. By that time, the medfly had already been on the march for over 100 years. From its native home in equatorial Africa, it had spread to the countries of North Africa and Southern Europe adjacent to the Mediterranean Sea. From there, it continued its spread to South America, to Australia, and Hawaii. In each of those places, its effect on agriculture was devastating. And in each of those places, medfly continues to wreak havoc even to this day. In Florida, however, the State Plant Board and the U.S. Department of Agriculture made a determined effort to eliminate this pest. And remarkably, they were successful. For the first time ever, the Mediterranean fruit fly was eradicated from an area it had newly invaded. Since then, Florida has continued to be a leader in the ongoing battle against invasive fruit fly pests from around the world. I am here in a healthy Florida orange grove, part of our thriving agricultural industry that contributes $97 billion annually to Florida's economy. Florida, of course, is famous for its citrus products such as oranges and grapefruit. Recently, a new initiative, the Citrus Health Response Program, was developed specifically to protect this important crop from an onslaught of plant diseases and insect pests, including fruit flies. However, not only citrus is subject to fruit fly infestation. Almost any fruit you can imagine is infested by some type of fruit fly someplace in the world. For an example, a very serious pest of papaya is called the papaya fruit fly. Similarly, there is an apple maggot fly, a cherry maggot fly, blueberry maggot fly, and peach fruit flies. Not only what we normally think of as fruits are subject to fruit fly infestation. There are a number of different fruit flies called melon flies, for example, that are very serious pests of squashes, watermelons, cantaloupes, cucumbers, pumpkins, and the like. These fruit flies tend to have a limited set of target fruits that they search out to infest. There are other fruit flies that are highly adaptive generalists that can attack a large variety of different fruits. These widespread and abundant pests often go by regional names such as the Oriental fruit fly or the Mexican fruit fly. The Mediterranean fruit fly is the most adaptive of all. It is able to infest over 250 different types of fruits. These include our big industry crops such as oranges and grapefruit, but also many types of fruits you might never imagine. These include hot peppers and the coffee cherries in tropical countries from which we get our coffee beans. Most of the important pests that we intercept over and over again in Florida tend to be these generalist species. Their ability to infest almost any type of fruit or vegetable virtually ensures that they will be able to find a suitable breeding habitat regardless of the place or the season in which they arrive. As we have seen, there are many different types of fruit flies and many different types of fruits that they may infest. However, the basic life cycle of all fruit flies is very similar. The fruit fly life cycle begins here. A female goes searching for an appropriate host plant. This is a ripe fruit or a green fruit, depending on the fly and the plant, but it's a healthy fruit on the tree. The female has an ovipositor, which is like a hypodermic needle. This allows her to pierce through the skin of a fruit and lay eggs into the fleshy interior. She may lay one or many eggs into a single fruit. The eggs are tiny, only 1 or 2 millimeters long, and not likely to be noticed. The eggs hatch in a few days to produce the larval stage, sometimes called worms or maggots. This is the feeding stage and the real problematic stage as far as people are concerned. The first larval stage is just as small as the egg and equally unlikely to be noticed. However, as the larvae feed They tunnel through the fruit, growing bigger and bigger, and leaving an expanding trail of damaged and decaying fruit pulp behind them. At this point, the consumer would see an obviously wormy and inedible fruit. By the time that larvae are full grown, the fruit may be so heavily damaged that it will have dropped from the tree. The larvae exit the fruit and burrow into the leaf litter or into the soil to transform to the pupal stage. The pupa is like a small cocoon in which the larval stage transforms into the adult form. The length of time to make the transformation depends on the season and the temperature. This stage typically lasts a week to 10 days in warm weather. Finally, we see the adult stage once again. Both males and females need a source of food and water and several days to several weeks to become sexually mature. A single mating event may allow the female to fertilize all of the eggs that she oviposits during the remainder of her life. Flies may live up to several months, and females may oviposit daily, producing hundreds or even thousands of eggs in a lifetime. Fruit flies may breed continuously when host fruits are available and temperatures are accommodating. For example, in warm lowland Hawaii, the Mediterranean fruit fly has a life cycle of less than 30 days and more than 12 generations occur per year. As I mentioned earlier, the larvae are the problem stage in the life cycle, as this is the feeding stage in which the fruit or vegetable is destroyed. These very early immature stages, the eggs and larvae, are a big problem in another sense too, as these are the stages in which these pests may be moved great distances from an infested area to a fly-free area. Fruit which contains only eggs or early larval end stages appear perfectly sound. They may be commercially harvested from groves or orchards or picked from dooryard trees, then moved across state or national boundaries or even between continents in a matter of hours. Eggs hatch and larvae continue to develop whether the fruit is on the tree or on the grocery store shelf. Once the infested fruit has traveled to a new area, development through larval, pupal, and adult stages all proceed as usual. As there is such a variety of fruits and vegetables from around the world that are brought into Florida every day, there is ample opportunity for many exotic and destructive fruit fly pests to hitchhike into Florida along with them. The Division of Plant Industry's fruit fly detection and monitoring programs are so important because of the ease and frequency with which fruit flies travel. Following are sections covering fruit fly monitoring and detection, identification, delimiting survey, fruit fly eradication, preventive fruit fly programs, and the Caribbean Fruit Fly Certification Program.
How would you like to be a homeowner with fruit trees in your backyard and you go out one morning to pick that special orange or grapefruit off of a tree, bring it inside, cut it open, and there's nothing but rot and maggots inside? This is something that you don't want and don't need, and neither does our industry. Florida's trapping program initially started on April the 6th, 1929, when a grove owner in Central Florida went out to his grove, found a tremendous amount of fruit lying on the ground, not knowing what was going on. He called in inspectors, they took samples, sent them away, and it was discovered that medfly was in his grove. This took over 2 years to eradicate at the cost of $7.5 million. Through the years, we developed different types of traps and also lures for the various economically important fruit flies. One was the McPhail trap, devised in 1937. It was a trap that used kerosene for a bait, and finding that medflies went to kerosene. After that, we came up with different types of pheromone lures and also bait traps, and our program really got started in 1997 when we set different criterias throughout the state. We increased traps from about 10 to 12,000 to 56,000 up to 60,000 throughout the state. In order to protect our multi-billion-dollar agricultural industry, we had to set up a program that would take care of these economically important fruit flies. Survey specialists are responsible for performing the activities associated with our fruit fly detection program. They are trained to recognize host plants and know the host preferences for our target pests. They place and service traps according to departmental guidelines, perform required trap relocations, and maintain proper trap densities and distribution throughout the state. Primary consideration for trap placement is given to high-risk introduction points such as international ports of entry, areas with potential for illegal fruit introduction such as densely populated areas, airports, and international food markets. Traps are also placed at residential home sites and on primary and secondary roads in rural areas. There are two main traps used in the fruit fly detection program: Jackson traps and multi-lure traps. Different bait mixtures and pheromones are used to attract a variety of targeted flies. Once an appropriate site has been selected, the survey specialist prepares new traps for placement. Traps are placed high enough in host trees to be out of reach of children, livestock, or pets. Traps are serviced every 3 weeks. The inserts of the Jackson trap are pulled out and examined. If flies are found, the insert is placed in a Ziploc bag, relevant information is recorded, and it is sent to the Fruit Fly Identification Laboratory for analysis. Next, the contents of the multi-lure trap are strained, and if flies are found, they are put in a vial of alcohol. The specimens are then sent for laboratory analysis. When traps need rebaiting, the specialist removes existing traps, replacing them with freshly baited traps. In general, traps are relocated every 12 weeks to new sites to ensure widespread coverage. Without this trapping program monitoring what's coming into this state from other countries, our citrus and our vegetable and tropical fruit industry would be devastated.
Hello, I'm David Dean with the Florida Department of Agriculture. I'm head of the Fruit Fly Identification Lab in Palmetto, Florida. This lab was established at the end of the last major medfly eradication that took place in Florida in 1998-99. We are here now supporting cooperative fruit fly detection and eradication programs throughout the state, cooperative programs with the United States Department of Agriculture and the Florida Department of Agriculture working together to do as early detection as possible of fruit flies in Florida. In this laboratory, we have about 10 to 12 personnel that 52 weeks a year are screening 250,000 fruit fly traps a year that are sent in here. In a year, we screen anywhere from 1.5 million to almost 3 million specimens of fruit flies. One of the things that complicates things for us is that we have a large number of native populations of fruit flies, and also the fact that we are releasing sterile flies. So at this laboratory, we support Caribbean Fruit Fly Certification Program, the General Fruit Fly Detection Program, and the Sterile Release Program. And then in the event that a wild fly is detected, then we are supporting what are called emergency detection, delimitation, and eradication programs.
After a preliminary examination in Dr. Dean's lab, all suspect fruit flies are sent here to the Gainesville lab for confirmation and further analysis. The identification process is critical to dealing with any new insect introduction into Florida. Because the biologies and host plants of different pests vary, we have to adjust our responses accordingly. So we take great care in the identification process to know exactly which insect we are dealing with and how to respond appropriately. Typically, we see the same insect pests such as Mediterranean fruit fly over and over again. Not infrequently, however, we are confronted with something we have never seen before in Florida. For that reason, we maintain a very large and diverse research and reference collection, the Florida State Collection of Arthropods, to assist us in identifying insects that may arrive from any place in the world. Once we have established a positive identification, we can launch an appropriate response. The first step is to begin a delimitation survey. That is, we establish a dense trapping grid in an 81 square mile area surrounding the detection site that will be monitored for several months. We also assess the immediate area around the detection site for potential host plants and check for infested fruits. If no further flies are found during a time period equal to 3 life cycles of that fly, we can rest easy and return to our normal trapping activities for that area. If we do find additional flies or infested fruits, Then we would proceed to an eradication program.
Once a fruit fly of concern has been positively identified and a trigger is reached that requires an eradication program, the eradication technique used depends on the type of fly found. For example, for oriental fruit fly, triggers include finding 2 adult flies within 3.5 miles of each other or finding larvae. There may be other triggers, but these are the main ones. For the oriental fruit fly, we have a specialized technique known as male annihilation. This is used to interrupt the reproductive cycle. Other control methods include soil drenching, foliar spot treatment, and fruit stripping. Division of Plant Industries control team is trained and ready to respond to a fruit fly outbreak at a moment's notice. Briefly, the control techniques include male annihilation. The male annihilation technique consists of applying a small amount of a thickened spray containing an attractant and a pesticide to inanimate objects, such as utility poles and street trees, from a slow-moving vehicle. The treatment area is defined by a minimum 1.5 mile radius beyond any infested site. Approximately 600 bait stations are applied per square mile every 2 weeks for 2 life cycles. Bait treatment may be applied by air to the infestation area if conditions warrant. Foliar spot treatments. Based on risk assessment, if aerial treatment is not deemed necessary, or if the male annihilation treatment is not effective, the foliage of host trees or other plants within the treatment area will be treated with insecticide sprays. Soil drenches. The soil under host trees with fruit known or suspected to be infested with fruit fly larvae may be treated. Soil treatments may be applied when larvae, pupae, or a mated female have been discovered on a property. Adjacent properties are also treated. Fruit stripping. Fruit will be stripped from all host trees on properties where larvae have been found and adjacent properties within 656 feet.
We have another important weapon in our fight against invasive fruit fly infestations, and that is the sterile insect release program. In the case of a widespread outbreak, we would release large numbers of laboratory-reared sterile flies during the final stages of an eradication program after other control measures had reduced the population to very low levels. This control method relies on flooding the area of a wild fly infestation with sterile flies. When sterile flies mate with fertile flies, no offspring are produced. Gradually, through continued sterile fly releases, the wild fly population decreases and the sterile fly population increases. When fertile flies can find only sterile flies to mate, the wild population is quickly eradicated. The size of the sterile release area will vary depending upon the severity of the outbreak. However, as a result of the devastating medfly outbreak in the late 1990s, as a preventive measure, the state of Florida, in cooperation with the U.S. Department of Agriculture, has been rearing sterile medflies at our Sarasota facility. The sterile flies, which have been genetically engineered to produce only males, are marked with a fluorescent dye. This allows us to distinguish them from any wild flies in the detection traps. We maintain a special trapping grid to measure how uniformly the flies are distributed. The sterile flies are released in 3 high-risk areas of the state: Tampa, Miami, and Sarasota-Bradenton. Over 40 billion sterile flies have been reared and released in the last 10 years. And while isolated incidences of wild medfly detections have occurred over the last several years, there have been no major eradication programs, due largely to the sterile release program. Costs associated with the sterile release program are only a fraction of what a full-scale eradication program would cost. These control methods prevent the establishment of invasive fruit flies in Florida. However, one pest, the Caribbean fruit fly, is already established here. The Caribbean fruit fly has become a serious pest of many tropical and subtropical fruits in Central and South Florida since its introduction in 1965. Rigid quarantine requirements have been established to prevent the spread of infested material and to provide a means of compliance and treatment. The carob fly protocol is a body of regulations under which fresh Florida citrus fruit may be certified free of the Caribbean fruit fly and shipped to those domestic and foreign markets that have established regulations for this pest. Some major countries such as Brazil, Chile, Japan, and the People's Republic of China, plus the states of California, Hawaii, and Texas have accepted this certification protocol. The certification program, which is grower funded, involves creating buffers around groves that are free of preferred carob fly host plants, monitoring carob fly detection traps, and in some cases, aerial spraying. The Florida Department of Agriculture is credited with the development of this highly innovative program, which has allowed the continued export of citrus, one of Florida's most economically important crops. The certification program was among the first of its kind and has been used as a model for others worldwide. With the carob fly protocol, a safe and effective procedure has been established to export Florida citrus to areas requiring quarantine measures. Safeguarding our food supply is a paramount responsibility of the Florida Department of Agriculture and Consumer Services. It has been many years since a major fruit fly infestation in Florida has required the kinds of drastic measures undertaken in Marjorie Kinnan Rawlings' day. At that time, all the fruit was stripped from the trees, top of the market bell peppers and eggplants were burned. Farmers were deprived of their crops and their livelihoods. However, the threat remains today. Fruit flies continue to arrive in Florida on a regular basis. In an 8-month period recently, 4 different types of fruit flies were detected in Florida, including the Mediterranean fruit fly. The Division of Plant Industry remains vigilant and successful in keeping fruit flies from becoming established in Florida. We maintain numerous programs, staff, and resources to intercept these destructive insects and to prevent the economic disaster they can inflict on Florida agriculture. Today, we are just as aware as the Floridians of Marjorie Kinnan Rawlings' day of the value of protecting our food supply. Miss Rawlings likely would be pleased to know that her fruit trees here at Cross Creek continue to flourish and be free of fruit fly infestation after these many years.